So now we're going to be talking about area and sector area. This is very similar to the circumference and arc length, except for instead of talking about the circumference or the perimeter of a circle, now we're talking about the area or the stuff inside the circle, not outside, but inside the circle. So in this one, we're going to find the area of some of the circles, and then we're going to find the area of sectors of the circles or chunks of the circle. To find the area, we're going to use the formula A is equal to pi r squared. Again, that A stands for area, and then R stands for the radius. In the last video, I showed you two different formulas, one for area, one that uses radius, and one that uses diameter. In this case, we can only use radius, so we'll always have to, if we get a diameter, we'll have to divide it by 2. And then the sector area, again, so let me show you an example, and then we'll come back to it, but the highlighted part is what we're finding. It's not necessarily just the outside, but it'd be like, in fact, let me show you with a highlighter. Basically what we're doing is we're finding this entire area right here. So like everything inside of this chunk, or everything inside of this chunk right here. Because now it's an area and not just a perimeter. But so it's just a slightly different formula. Still uses the same information though. So to find the sector area, you have to first decide if you have your angle in degrees or if you have it in radians. If you have it in degrees, the formula is that the area of the sector is pi r squared times theta over 360, where r stands for your radius and then theta stands for the angle in degrees. And then if you have your angle in radians, the area of the sector formula is r squared times theta over 2, where r again stands for radius and theta stands for the angle in radians. Depending on what you want to do, you could potentially convert between degrees and radians if there's a formula that you like more. But we're in these examples, we're just going to use the two different formulas so that we don't have to convert between degrees and radians or radians and degrees. All right, so let's start with the first example. In the first example, we're just looking for the area. And the formula for area is equal to pi r squared. So we need to find the radius, and in this case, the radius is 10 miles. So all I'm going to do is replace the r in my equation with 10. So I have pi times 10 squared, and I can plug that into a calculator. And because pi is an irrational number, your answer will be a gross decimal. That's totally fine. I just want to round to the nearest hundredth. So we're going to say A is equal to 314.16. And because our radius is measured in miles, our area will be measured in miles squared. So in the last video, it was just measured in the same units, and this is still measured in the same units, but because it's an area, it has to be squared. When we measure area, it's in square units, and so all of our answers will have square units at the end of them. All right, so now let's go to the next one. The next one, again, is asking us to find the area, so our formula we're going to use is area is equal to pi r squared, but this time it doesn't give us a radius right off the bat. Like I said, there's not a formula that uses diameter, so what we need to do is take the diameter and find the radius. We know that the diameter is 2 times the radius because it's the radius we know goes from the center out, and that happens twice. It goes from the center out this way and then from the center out that way. So the diameter is 2 times the radius. If we use that, and I know the diameter is 19.4, then what I can do is just divide each side by 2 to figure out the radius. So the diameter divided by 2 is the radius. If I do 19.4 divided by 2, I get 9.7. So we know r is 9.7. And now all I have to do is replace the r in my area equation with 9.7. So I'm going to say area is equal to pi times 9.7 squared. And now I can plug that into my calculator, and I end up with area is equal to 295.59, and then that would be in meters squared or square meters. And that's my area. Again, the area is what's inside the circle, all of it, everything that's inside the circle versus the perimeter, which was the circumference that we talked about in the last video. All right, so these next two questions ask us for the area of the sector. So basically like the blue highlighted part. And because they're measured in two different things, we have to use two different formulas. The example number 3 is measured in degrees. The angle is measured in degrees. So we have to use the formula for degrees, which would be pi r squared times theta over 360. So we need our radius, which is 10, and we need the theta, which is the 225 degrees. So I'm just going to replace those in my equation, which would give us pi times 10 squared times 225 over 360. And now all I have to do is plug that into my calculator. And then, let's see, I end up with that the area of the sector is equal to 196.35. And again, this is still an area. Even though it's not the entire area, it is still considered an area of a chunk of the circle. So our measurement would be in meters squared or square meters. So we get 196.35 square meters. All right, the last question is in radians. The angle measures in radians, so we have to use a different formula, which is r squared times theta over 2. Again, we need the radius, which in this case is 11, and we need the theta, which is the 19 pi over 12. So I can write the area of the sector is equal to 11 squared instead of r squared times 19 pi over 12 for our theta, and that's all divided by 2. And I'm just going to plug all of that into my calculator, and I end up with that the area of the sector is equal to 300.94, and this would be in square miles or miles squared because it's still considered an area. All right, and there we have it. This is how we find the area of a circle and area of a sector of a circle.